With the summer weather getting warmer and your AC on high, you might be wondering, how do ACs work? To answer that question, we're going to need to talk about heat transfer. ACs cool down hot air by transferring that heat somewhere else, and they do this using phase conversions. A phase conversion is when a substance changes from one phase to another. ACs use the conversion from liquid to gas. Changing a liquid into a gas absorbs energy from its surroundings. For example, to boil water, you need to heat the water and add energy. The reverse phase conversion from gas to liquid releases heat into the environment. Think about water vapor condensing on a cool can of soda. These phase conversions are what allow ACs to transfer heat from air, which cools down the air. This is the basic circuit used by an AC. A chemical called a refrigerant undergoes a series of phase conversions. It starts out as a liquid. The refrigerant travels to an expansion valve where it expands, becoming a gas. Remember, this process absorbs heat. Next, the gaseous refrigerant travels through tubes to a compressor. Under high pressure, the gas becomes liquid again. This process releases heat. Now, the refrigerant is liquid again, and the process repeats over and over. What's really cool is that this process doesn't require any external energy input. All the heat transfer is done by a series of phase conversions. So, now that we know how heat is transferred in an air conditioner, how do ACs actually cool down a room? Well, let's take a look at a window AC. The left half of the AC is inside the room, and the right half is outside. First, our liquid refrigerant travels to the expansion valve, where it becomes a gas. The gas travels through a series of tubes called condensing coils or hot coils. Here, the gas releases heat and transfers it to the air. The air becomes warmer. A fan blows the hot air outside. Next, the gas travels to the compressor and becomes a liquid again. After, the liquid travels through another series of tubes called evaporator or cool coils. The opposite phase conversion happens. Liquid refrigerant absorbs heat from its surroundings. So the air transfers heat to the refrigerant, which cools down the air. Then, a fan moves this nice, cool air into your room. Now, you may be wondering, what is refrigerant? Refrigerants are the chemicals used in air conditioners that change from liquid to gas at low temperatures. This means that refrigerants have a low boiling point. All of these commonly used refrigerants have really low boiling points. For comparison, water has a much higher boiling point of 100 degrees Celsius. The low boiling point means that it's easy to convert these chemicals from liquids to gases. The process doesn't take a lot of energy, which makes them good refrigerants. However, one problem with refrigerants is that they can leak out of the AC and into the environment. Many commonly used refrigerants, like Freon and dichlorofluoromethane, contain chlorine, which can deplete the ozone layer when released into the environment. Most new ACs use refrigerants without chloride groups, like fluoroform. It's not a perfect solution because although fluoroform doesn't deplete the ozone layer, it is a greenhouse gas. Thank you for watching this video. If you have any questions or topics you'd like us to cover next, please comment them below. And, as always, be sure to like and subscribe for more videos about chemistry, biology, and everything STEM related.